By 2026, your Kubernetes cluster will be running hundreds of AI agents that don't speak the same language. And that's when everything breaks.
Wait, are you saying we're heading for an agent communication crisis? So we're covering the standardization gaps, the security nightmares, and what cloud-native agent frameworks actually need?
By minute 4, you'll know exactly which standards to adopt before it's too late. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into cloud-native agentic standards.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been keeping platform engineers up at night lately: cloud-native agentic standards. We're seeing this fascinating collision between two worlds that honestly weren't designed to work together. On one side, you've got Kubernetes and the cloud-native ecosystem that's all about predictable, containerized workloads. On the other side, you've got AI agents that are, by definition, unpredictable and autonomous.
Right. And I've been seeing more teams trying to deploy these AI agents in production. But it feels like we're trying to fit a square peg in a round hole sometimes. What exactly makes AI agents so different from traditional microservices?
Great question. Think about it this way. When you deploy a traditional microservice, you know exactly what it's going to do. You send it a request, it follows a deterministic code path, returns a response. But AI agents, they're making decisions based on context, they're reasoning through problems, and they're potentially taking actions you didn't explicitly program them to take.
That sounds like a security nightmare waiting to happen.
It absolutely can be, and that's why we're seeing this push for standardization. The document we're looking at today defines an AI agent as a containerized application that can operate independently or as part of a distributed system. But here's the kicker. It uses AI or ML capabilities to reason and execute actions within event-driven systems. That's fundamentally different from anything we've dealt with before in the cloud-native world.
So we're not just talking about running an LLM in a container. This is about autonomous systems that can plan, orchestrate, and even govern their own execution.
Exactly. And the implications are massive. We're talking about systems that can do multi-hop reasoning, where an agent doesn't just respond to a single prompt, but can chain together multiple decisions and actions to achieve a goal. Imagine deploying hundreds or thousands of these agents in a Kubernetes cluster, all potentially interacting with each other, making autonomous decisions, and modifying system behavior in real time.
But how do you even begin to manage that? Traditional Kubernetes security policies and RBAC weren't designed for workloads that can essentially think for themselves.
And that's precisely why the standardization effort is so critical. The teams working on this have identified 4 key areas where we desperately need standards: interoperability between agents, security controls for autonomous systems, observability into non-deterministic behaviors, and governance frameworks that can adapt as these systems evolve.
I'm particularly interested in the observability angle. How do you debug something when you can't predict what it's going to do?
That's one of the most fascinating challenges here. With traditional microservices, you can trace through the code, set breakpoints, understand the logic flow. But with AI agents, the logic is often a black box neural network making probabilistic decisions. You might get different behaviors from the same input depending on context, previous interactions, or even just random initialization.
This reminds me of the early days of microservices when we were figuring out distributed tracing, except now we need to trace not just service calls, but actual reasoning chains.
Precisely. And here's what's really interesting. The document explicitly states that these recommendations are focused exclusively on Kubernetes environments. They're not trying to solve this for every possible deployment scenario. They're saying, look, Kubernetes has become the de facto standard for container orchestration, so let's build our agentic standards on top of that foundation.
Makes sense. No point reinventing the wheel when you already have a robust orchestration platform.
But here's where it gets really interesting. They're also acknowledging that this isn't a one-and-done standardization effort. The document literally says it's not intended to be exhaustive and will continue to evolve. They know that AI capabilities are advancing so rapidly that any standards need to be flexible enough to adapt. Coming up, we'll dig into exactly how these standards address the unique challenges of deploying AI agents at scale, including some surprising security recommendations that go way beyond traditional container best practices. So let's dive deep into what these standards actually recommend. The first thing that jumped out at me is how they're approaching security. They're not just saying, follow container best practices. They're acknowledging that AI agents introduce entirely new attack vectors.
Like what? I mean, beyond the obvious concerns about prompt injection or model poisoning.
Well, think about the principle of least privilege in a traditional container context. You give a container access to only the resources it needs, right? But how do you apply that to an AI agent that might need to dynamically discover and interact with other services based on its reasoning?
Oh, wow. I hadn't thought about that. You can't predetermine all the resources an autonomous agent might need.
Exactly. So the standards are proposing this layered approach. At the base layer, you still have traditional container security, minimal attack surface, non-root users, read-only file systems where possible. But then they add what they call reasoning-aware security policies.
Reasoning aware? That sounds complex.
It is. Essentially, they're proposing that security policies need to understand and constrain not just what actions an agent can take, but what reasoning paths it can follow. For example, you might allow an agent to query a customer database, but only if it's following a specific reasoning chain related to customer support, not if it's trying to do competitive analysis.
That's fascinating. So we're moving from static RBAC to dynamic, context-aware permissions?
Right. And here's where the observability piece becomes critical. The standards recommend what they call reasoning chain logging. Basically, every action an agent makes needs to be logged with full context about why it made that decision. Not just Agent A called service B, but Agent A determined it needed customer data because of reasoning steps X, Y, and Z.
That sounds like it could generate massive amounts of log data.
You're absolutely right, and they address that. They're recommending a tiered logging approach. Level 1 is basic action logging. What did the agent do? Level 2 adds reasoning context. Why did it do it? Level 3 includes full prompt and response data for debugging, and Level 4, which you'd only enable for troubleshooting, includes internal model states and attention weights.
Oh, that's clever. So you can dial up the verbosity when you need it without drowning in data during normal operations.
Exactly. And they're also proposing standard metrics specifically for agentic systems. Things like reasoning chain depth. How many steps did an agent take to reach a decision? Autonomy utilization. What percentage of decisions required human intervention? Inter-agent communication frequency. How often are agents talking to each other?
That inter-agent communication piece seems particularly important. How do they handle that?
This is where it gets really interesting from a platform engineering perspective. They're proposing a standard protocol for agent-to-agent communication that builds on top of existing service mesh capabilities. So you'd use something like Istio or Linkerd for the transport layer, but adds semantic layers on top for agents to negotiate capabilities, share context, and coordinate actions.
So agents could essentially discover what other agents are capable of and dynamically form collaborations.
Precisely. And here's a concrete example from the standards. Imagine you have a customer service agent that needs to process a refund. It discovers there's a fraud detection agent in the cluster. The customer service agent can query the fraud agent's capabilities, share relevant context about the refund request, and get a risk assessment, all through standardized protocols.
But what prevents agents from forming, I don't know, unintended collaborations, like agents working together in ways we didn't anticipate?
That's the million-dollar question, isn't it? The standards propose what they call collaboration policies, essentially rules about which agents can talk to which other agents and under what circumstances. But they acknowledge this is one of the areas that needs the most research and refinement.
It's like we're building distributed systems where the components can rewire themselves at runtime.
That's a perfect analogy, and the performance implications are significant. Traditional Kubernetes scheduling assumes relatively predictable resource usage, but AI agents can have massive variance in compute needs depending on the complexity of the reasoning task. The standards recommend new scheduling hints specifically for agentic workloads, things like maximum reasoning depth or expected token generation rate.
Are there any real-world implementations of these standards yet?
We're seeing early adopters in financial services and healthcare, industries where you need both the power of AI agents and strict compliance controls. One bank I know of has deployed a multi-agent system for fraud detection that follows many of these principles. They're seeing 40% better fraud detection rates, but more importantly, they can actually audit and explain every decision the system makes. All right, let's talk about what platform engineers should actually do with all this information. Because reading standards is one thing, but implementing them is another entirely.
Yeah, where do you even start? It feels overwhelming to retrofit existing Kubernetes deployments for AI agents.
The good news is you don't have to do everything at once. The standards actually lay out a maturity model. Level 1 is just basic containerization. Make sure your AI agents are properly containerized with health checks, resource limits, and basic observability. Most teams can achieve this pretty quickly.
That makes sense. Start with the fundamentals we already know.
Right. Level 2 is where you add reasoning-aware security policies. Start simple. Maybe just log when agents make autonomous decisions and require approval for certain action types. You can use existing tools like Open Policy Agent, just with policies that understand agent behaviors.
So you're gradually building up the control plane for these autonomous systems.
Exactly. And here's a concrete checklist for teams starting this journey. First, implement structured logging for all agent decisions. Use a schema that includes the agent ID, reasoning chain, confidence scores, and actions taken. Second, set up distributed tracing that can follow reasoning chains across multiple agents. Third, implement circuit breakers for agent interactions. If agents start communicating too frequently or in unexpected patterns, you need to be able to throttle them.
What about the security side? That seems like it should be priority one.
Absolutely. Start by implementing what I call capability passports for your agents. Each agent should explicitly declare what capabilities it has and what resources it needs access to. Then use admission webhooks in Kubernetes to validate these passports before deployment. No agent gets deployed without a clear declaration of its intended behaviors.
Oh, that's clever. It's like static typing for AI agents.
I love that analogy. And just like static typing, it catches a lot of problems before they hit production. And another critical security measure is implementing reasoning firewalls, basically runtime checks that ensure agents aren't exceeding their declared capabilities or accessing resources outside their scope.
How do you handle the observability challenges we talked about? The non-deterministic behavior seems like it would make debugging a nightmare.
The key is to think differently about debugging. Instead of trying to reproduce exact behaviors, focus on understanding reasoning patterns. Implement what I call reasoning replay, the ability to take a logged reasoning chain and understand why an agent made specific decisions. Tools like Langsmith or Weights and Biases are starting to add features specifically for this.
What should teams be watching for as these standards evolve?
Great question. I think we're going to see 3 major developments in the next 18 months. First, native Kubernetes resources for AI agents. Imagine being able to kubectl apply an agent resource, just like you do with deployments today. Second, standardized benchmarks for agent performance in cloud-native environments, not just accuracy metrics, but operational metrics like resource efficiency and scaling behavior.
And the third?
The emergence of agent mesh technologies. Think service mesh, but for AI agents. These would handle agent discovery, capability negotiation, and secure communication automatically. We're already seeing early prototypes from some of the major cloud providers.
This really does feel like we're at an inflection point, similar to when containers first appeared.
It is. And here's my advice for platform engineers. Start experimenting now, but be thoughtful about it. Pick a non-critical workload, implement basic agent standards, and learn from the experience. The teams that figure this out early are going to have a massive advantage as AI agents become more prevalent.
Any final thoughts on where this is all heading?
I think we're witnessing the birth of a new computing paradigm. We've gone from monoliths to microservices, and now we're moving to what I call cognitive services, systems that can think, reason, and adapt. The platform engineers who master these cloud-native agentic standards aren't just managing infrastructure anymore. They're essentially building the nervous system for intelligent applications. And that's both incredibly exciting and a little bit terrifying.
Well said. It's definitely a space worth watching closely.
Absolutely. And for those listening who want to dive deeper, check out the full CNCF working group on agentic standards. They're actively looking for feedback from practitioners in the field. This is our chance to shape how AI and cloud-native technologies evolve together. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in enterprise networking. Colt just launched a multi-cloud SD-WAN offering specifically targeting digital transformation in Europe. According to Total Telecom, they're promising superior security, increased agility, and lower latency.
Multi-cloud SD-WAN seems to be the hot ticket these days. What's making Colt's approach different?
They're focusing heavily on the European market and emphasizing the security angle. With all the regulatory requirements in Europe, that's probably a smart play.
Makes sense. Speaking of infrastructure, here's an interesting take from Construction Dive. They're arguing that investing in infrastructure is actually crucial for making housing more affordable.
That's not the usual angle we hear in platform engineering, but I can see the connection. Better infrastructure means more efficient development and deployment of services that support housing projects.
Now, here's something directly in our wheelhouse. CNCF and Slashdata just released a report showing the cloud-native developer community has reached 19.9 million globally as of Q1 2026.
That's massive growth. They surveyed over 12,500 developers to get these numbers. The cloud-native ecosystem just keeps expanding.
And speaking of CNCF, IBM, Red Hat, and Google just made a significant donation. They've contributed LLMD, a Kubernetes blueprint for LLM inference.
This is huge. According to the new stack, this project aims to standardize and simplify deploying LLMs at scale. Making LLM inference a first-class citizen in Kubernetes could be a game changer.
Definitely. And CNCF isn't slowing down on the AI front. They've nearly doubled their certified Kubernetes AI platforms and added agentic workflow validation.
The Cloud Native Now reports this expansion shows growing maturity in the Kubernetes AI ecosystem. The fact that they're adding agentic workflow validation is particularly interesting.
Now, let's talk about some critical security releases. NATS Server just pushed out 2 security updates, versions 2.12.6 and 2.11.15.
These are addressing multiple CVEs, including CVE 2026-33216, 33217, and 33215 that affect systems using MQTT, plus CVE 2026-33246 for leaf nodes and service imports.
Both releases update golang.org/x/crypto to v0.49.0 and JWT/v2 to v2.8.1. If you're running NATs with MQTT or leaf nodes, you'll want to update immediately.
Absolutely. The 12.2.6 release is on Go 1.25.8, while they're maintaining backwards compatibility for the 2.11x branch. Good to see them supporting multiple versions with security patches.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.